This lesson introduces graphing trig functions. It turns out that the graphs of trig functions, in particular sine and cosine, are quite interesting and useful in both modeling real-world situations as well as just creating very interesting and appealing designs. A couple of important points. You should copy these points into your notes. They might not be as meaningful now as they will be after we finish our study of graphing. But we're always going to graph the x-axis with radians, not degrees. And one of the things that will be important as we start looking at more complex graphs is that you choose your scale for the x-axis carefully. Zeros, meaning where the graph crosses the x-axis. Maxima and minima, that's the highest and lowest points on the graph. Those should be accurate, and the general shape of the graph should be accurate. Again, these 4 points will become more meaningful as you learn more and practice constructing these graphs. I'm going to show you first how to create the graph for sine, y equals sine of x. And it might be very useful to have your unit circle in front of you so you see where I'm getting these values. The sine of 0, if x is 0, the sine of 0 is 0. The sine of pi over 4 is root 2 over 2, and the sine of pi over 2 is 1. The sine of 3 pi over 4 is root 2 over 2. The sine of pi is 0. The sine of 5 pi over 4 is negative root 2 over 2. The sine of 3 pi over 2 is negative 1. The sine of 7 pi over 4 is, negative root 2 over 2. And the sine of 2 pi, well, we're all the way back around the circle, so that's 0. And when I go to graph this, it's going to be useful for the sake of graphing to have an approximation. So root 2 over 2, let me plug that into my calculator. Square root of 2 divided by 2 is about 0.707. So that will help me when I go to draw the graph. Alright, so let's now put some axes here. And I've already chosen the scale for you. You'll see that it's appeared there. Again, as we start doing more complex graphs, choosing the scale is going to be one of the important steps before actually drawing the graph. So now I'm just going to start plotting points. The first table in my column, or the first column in my table tells me that when x is 0, y is 0. So the point I'm going to graph is 0, 0. And then when x is pi over 4, the sine of pi over 4 is root 2 over 2, which is about 0.707. Here's 0.5, so 0.707 is probably about there. And then when x is pi over 2, y is 1. And then for 3 pi over 4, it's back to root 2 over 2. And then when you hit pi, the sign is 0. And then when we go to 5 pi over 4, now it's negative root 2 over 2. And then it goes down to negative 1, back up to negative root 2 over 2, and then back to at 2 pi it goes back to 0. So this is a maximum, that's the highest the graph gets. This is your minimum, that's the lowest the graph gets. And then these points along the x-axis are x-intercepts. So now I'm just going to sketch in the general shape, and this is hard to do on my tablet, but I think that gives you the idea. And of course it keeps going, as well as in the other direction it keeps going, and we'll talk more about that in class. I encourage you to actually graph this on your calculators. Make sure you're in radian mode, and play around with your calculator graphs to get a better idea of what the sine wave looks like. And it is called the sine wave because of its shape, and that is also why it is useful in modeling real-world phenomenon. Anything that goes up and down is probably going to be modeled with sine or cosine. And also, like I said before, it creates kind of appealing pictures, especially if we extend it into 3 dimensions. For your homework, I want you to do the same thing for cosine that I did on the previous screen for sine. So first, fill out the table of values. Use your unit circle to help you if you find that a good strategy. And then plot the points and then sketch the graph for cosine. It should also be a wave. It should look quite similar to the graph of the sine wave. And please do that on graph paper. Have that ready for class next time.